Reflection is our new topic we are going to see. Under reflection, we are going to focus. I think we've seen how we use mirrors. So if we have a mirror, then a reflection. Anyone with a mirror? Okay. When you look in a mirror, you see an image. We call it an image in there. So it appears as if it's inside. So that's what we are going to focus on. But still, we are going to, based on the ideas of the line of symmetry. Then the line of symmetry will add us, and then we'll go to the reflections. So, under this topic, you will learn how to identify lines of symmetry or figures and apply reflection in the Cartesian plane. We are going to see why we start with lines of reflection here. So, identifying line of symmetry or figures. Actually, so these ones I think we saw in one of the chapters we covered earlier on how we get lines of symmetry. So, in our groups of 3, perform the steps below and write down your observations. 1, get a rectangular sheet of paper. Okay, let me get also one so that we can perform together. I want all of you, let us do it together. So, get the rectangular sheet of paper. Everyone get the paper, get the paper. They are there. You can choose. You can take in the groups of 3. So get the rectangular sheet of paper. I think this is rectangular. Okay? Yeah, most print papers are rectangular. Okay. Fold it from top to right. From left to right. So I fold it from left to right. So you see, can we? This is my right, this is my left. So from left to right, we fold it as the question is telling us. You can fold it like this or like this. Okay. So we are folding it. Are we there? Okay, fold it together. Do it the way I'm doing as we observe. Okay, I'm also doing it because I had to be having the same as you. Okay. Unfold the paper. What do you notice? So you know that they are telling us that. Unfold the paper. What do you notice? What do you notice? Okay, now I'm asking you, what do you notice? You are seeing a line. So you're seeing a line or a fold. This is a fold, but she's calling it a line. So, are you all seeing that line? Are you all seeing that line? Okay. So, I'm seeing the line, okay? So that's one of the observation, or one of someone is able to notice that. Any other observation? Yes. The 2 sides are equal. Which 2 sides? This and this, or on the left of the line and right of the line. So someone is telling us that this side is equaling to this side. Someone is telling us that this side is equal to this side. Okay. So you are able to notice those 2 things. Okay. Is there another observation? No another observation? Okay. So, when something is dividing an object into 2 equal parts, because you have told me these 2 parts are equal, how do we call, what can we call, what name can we give to this line? Someone called it a line. What name can we give to this line? Yes, the line of symmetry. So, this fold is called a line of symmetry. Why is it called line of symmetry? Yes, because it divides it into 2 equal parts. Okay, let us come to my number. For everyone, get back the paper. Repeat the steps when folding from top to bottom. So now I'm going from top to bottom. From top to bottom, like this. Okay, what do you notice there? What do you notice? From top to bottom, now I'm seeing I've created another line. So when I create this line, what do I notice? Are these two also equal? Are they equal? Yes, so this one becomes also a line of symmetry. So when I unfold it, how many lines do we see? How many lines do we see? Yes, 2 lines. So which figure is this? The whole of this, which figure is this? Rectangle, right? So rectangle has how many lines of symmetry? How many lines of symmetry? We look at it. How many lines of symmetry does it have? Has 2 lines of symmetry. So everyone, can you make individual notes about the rectangle and its line of symmetry quickly? So that's first of all the first exercise. We are going to go back in your individual notes book, and then you do this, and then you notice all the things you are able to notice, and then you put down what you notice in your box. Okay. So when we come to activity, the next activity, in your groups, find the number of lines of symmetry of the following figures. So here we have a rectangle, that's the shape. Then they're asking us how many lines of symmetry. We have a square, the shape, same circle, up to when we reach the circle. So then they also telling us, in your groups, present the diagrams showing lines of symmetry of the figures above. So these figures above. So can we do this? Can you try to do this? Then you show me your working. I'm going to sample 2 groups or 1 for this. So can we start? Okay, which group is that? Okay, you bring your work. Okay, our time is done. So I have this is group 8. These are the diagrams they are having for us. So we are filling them here. Group 8. Are we all able to see here? So this one they are having. They are having the same circle, isosceles triangle, equatorial triangle, circle, rectangle, square. They have 6 shapes, but we have 7. Where is the other one? I think most of you can see. So the last line of symmetry. Okay, I used this in the last lesson. So line of symmetry of a rectangle. How many lines of symmetry? That one I think was the easiest. I never saw the name group fail because we saw it here, right? So these ones were 2 lines of symmetry. So when it comes to a square, this one is a square. The last of the square has 4 lines of symmetry. So for a square, if you can divide this paper into 2, here, let me get anyone with a scissor? Okay. You really that scissor, so you see what happens there. So you want to divide that into square and see if the lines of symmetry are going to be the ones they are telling us there. Hope everyone can make a square. Can you make squares there? Okay, I've managed to get something similar to a square. I think you can all see. Okay, for that they are telling us they are having 4 lines of symmetry. Let us follow this together. Everyone gets something like this. Okay, can we start? Okay, let's start by folding it from up to down. Do you all agree that this line of symmetry? Okay, let us fold it now. Again, we change and then we fold it. Do you have that this is also line of symmetry? Okay. Now let us fold it like this. This edge to this edge down, or that corner to that corner down. Let us try and see. Yeah, you see? Mine, you see, it's giving me another one. So, hope you can see it. So this is what also line of symmetry. From this corner to this corner. Okay, that's also fold it. From down there to this side, let us fold it there. From down there to another corner. Hope you can see also. So how many lines of symmetry do you see there? How many do you see there? There are 4. Okay, so this one from here up to here, from here up to here, from here up to here, then from here up to here. So they are telling us there are 4 and we are able to see the 4. So this is okay. This is also very okay. Then the same circle. I think people can draw the same circle. So now the same circle, right? I think this is the easiest. It's that the only way when you divide this into this side is going to be equal to this. So the same circle has 1. Is okay. Then you come to isosceles triangle. What do you know about isosceles triangle? Yes, 2 sides, only 2 sides are equal. So that's why you say that these 2 sides are equal. So these 2 sides are equal to mean that they are telling us that it has only 1. So these are diagrams which they are using to show the lines of symmetry. So they are telling us this line of symmetry is also 1, and they are very right. Then we have an equilateral triangle. Who can define for us what an equilateral triangle is? Yes. A triangle with 3 sides equal, with all the 3 sides equal. If the 3 sides are equal, what does it mean? Even angles are equal. Okay. Anyway. So if these 3 sides are equal, so how many lines of symmetry do they see? They have 1, 2, 3. They solved 3 lines of symmetry. So now this is going to be exercise. Go measure 3 sides where they are equal. You can measure 5 centimeters, 4, 10 centimeters, when all sides are equal to 10 centimeters or 6. It's up to you. Try to show me that you are making, you can able to fold and you get these lines you've seen. 3 of them. I want to bring, when you bring your books, check your notes, you bring this with you. Then a circle here, they are telling us they are having only 2. So these ones they are saying, these are 3. What about scalene triangle? I didn't say scalene triangle. Anyone with the lines of symmetry of a scalene triangle? First of all, it's a scalene triangle. A triangle with 2 sides equal. But you said the triangle with 2 sides equal is an isosceles triangle. Can you rectify that? When sides are not equal to no sides. So it's saying that a triangle with its side not equal to the other. That's what they call a scalene triangle. So a scalene triangle will never do anything like line of symmetry. What does it mean? Where is group 8? Why did you draw for this? It has 0. Where do you practice that so that it has 0? You measured. So this side was 8. Then this was 12. Then this was 6. So you couldn't draw a line of symmetry. So it has 0. Okay. So this one has 0 lines of symmetry that I have indicated. Then a circle they are telling us it's having 2 lines of symmetry. So do you all agree? And I look with the different ideas. So this is okay. This is also okay. And this is okay. Then a circle has, they're telling us that a circle has 2 lines of symmetry. Do you agree? How many agree? Now you are many. How many are not agreeing? only 2. Why I don't agree? First of all, you are saying it has how many? 1. Someone is saying the circle has 1 line of symmetry. Why I say so? Because you can only fold it, but you can also fold it from here up to here and from here up to here. Then we are towards the other one. It has no line of symmetry. Someone is saying it has a line of symmetry. You mean when you can't fold it and you get 2 equal parts? Okay. Anyway, so for a circle, it has infinite lines of symmetry. For them, there are many. You can't point them out. There are many, because even here you can fold it into equal parts. Even here, even here. So here, that is no. So the circle has an infinite number of lines of symmetry. You cannot, no one can find them, because you can fold it at any part and you get 2 equal parts. So you can try that in your free time. That you can fold it. From here, you can fold. From here, you can fold. From here, you can fold. From here. So for it, it has an infinite number of lines of symmetry. So these ones, how many? We had 1, 2, 3, 4, 5, 6, 7. So they are getting 6 out of 7. Anyway, this one has infinite lines of symmetry. So you can't exhaust them. Unlike these ones, for them you can see this circle has 1. You can easily divide it into 2. But you can't divide. When you divide it from here up to here, they won't be the same. So that's the difference between a circle and a semicircle. Anyway, can you clap for ourselves? Now your task is, what is your task? What is your task? I think by now you know what you are going to do. What's the task? To go and make your own notes. So they know. So you can make your own notes, then represent these notes in your book, in the video books. See you tomorrow.